Students, in our today's class we are going to discuss the chapter that is our logarithm. Okay, so what exactly we mean by the logarithm is that it's very simple. Okay, you can see here a logarithm always shows the relation of the base of a number with its index. Okay, so I'm repeating it again. Okay, logarithm always shows the relation of the base of a number with its index. Okay, or you can say in other words, this chapter gives us the rule to simplify the mathematical calculations. Okay, I am repeating it once again. Okay, this chapter gives us the rule to simplify the mathematical calculations. Okay, now see how it helps us to simplify the mathematical calculations. So students, any positive real number, okay, any positive real number, so if I consider, okay, I am writing it here, any positive real number n can be expressed, okay, any positive real number n can be expressed in two ways. Okay, any positive real number n can be expressed in two ways. Okay, any positive real number n can be expressed in two ways. So here n I have considered as any positive real number. Okay, this is not a natural number. This n is considered as any positive real number. Okay, now this any positive real number n can be expressed in two ways. The first way is your exponential form. Okay, the first way is your or you can say exponential representation. Okay, and the second one is your logarithmic representation. Okay, the second one is your logarithmic representation. Okay, any number, okay, any positive real number n can be represented in two ways. One is the exponential representation that we have discussed in our earlier classes, and the second one is your logarithmic representation. So we'll try to understand both the representations. Okay, now let's take an example. Okay, this I have said n is any positive real number, so I'll consider a number here that is your 36. Okay, now see how this 36 can be represented in a two way. I will show you one in exponential representation, and second one will be the what your logarithmic representation. Okay, so you can see here, okay, these are the two ways. Now see here, this 36 6 square equal to 36. Can I write like this? Okay, this 36 can be written as what? 6 square equal to 36. Okay, here this 2 is called what your, here this 2 is called what your, this is called your power. Okay, so sometime we are saying this is degree also, or sometime we are called it as what your exponents also. Okay, sometimes it is named as exponents also, and this 6 is what your base here. Okay, and just I have said here n is any positive real number, so this n is actually what your here 36. Okay, this positive, because 36 is positive real number. Okay, this 36 is what your positive real number. So now this whole lot of representation is called what your, this is called your exponential representation. Okay, so this is called what your, this is called our exponential representation. Okay, this is called our exponential representation. Okay, this is very simple, we have discussed in our earlier classes as well. The second one is what your logarithmic representation. Now it's very much important to understand what exactly we mean by the logarithmic representation. Okay, so if I write log, okay, now if I write log, which means your, see, I'm writing base as a 6 and I'm writing here 36, and the answer is your 2. Okay, now see here, log of your 6 base 36 means it is very simple that we are what we are saying is that, okay, what power of 6, okay, what power of 6 gives us 36, okay, which means I am repeating it again, what power of 6 gives us 36, okay. So what power of 6 gives us 36? That is your 2, okay. It's very simple. This the way we're writing, which means what power of 6 gives us 36. Now what power of 6 gives us 36? 2, because we know 6 square equal to 36. So this is called what your, this is called your logarithmic representation. But here also this 6 is what your base, and what is this 2? This 2 is what? This 2 is exponent here, okay. This 2 is exponent here, which we have here, okay. And this 36 is what your n here, okay. It's very simple. So to write anything in logarithmic form means what we are trying to say is that, or what they are asking us is that, writing in that way means what power of this base, okay, what power of this base gives us this n. Now say example, you can think of 6 power 1. Now 6 power of 1 is how much? 6. You are not getting 36. 6 power of 2 is how much? 36. So 6 power of 2 is 36 now, so answer is 2. Or you can thought of 6 cube. Now if I write 6 cube, it will exceed 36, so acceptable is what your 6 square is 36. So our answer is what here? 2, and this 2 is degree. That's why I wrote here 2 as what your exponents, okay. It's very simple. Now see here, this is called what your, this is called our logarithmic representation, okay. This is called your logarithmic representation, okay. This is called your logarithmic representation. This is called what your exponential representation. But let me clear one more thing. This is logarithmic representation, even though we are saying this is an exponential representation, but actually this is called what? This is called the antilog as well, okay. This is called what your, this is called your antilog, okay. We'll discuss in our forthcoming videos, okay. So this is called what your antilog. That means this exponential representation is also called what your antilog. When it is log, now what is anti means? What anti means? Reverse of everything. So reverse of log is what? Antilog, okay. This is your log, this is the reverse, so we can name this one as antilog, okay. It's very simple, as simple as that, okay. Now, okay, now we'll try to understand with few examples, okay. Okay students, see, I have explained this log exponential form and logarithmic form with the help of 36, okay. Now as I have mentioned here, what I have mentioned here, n is as a positive real number, so I'll show this representation in the form of n as well, okay. Now see how to represent this one, okay. Now in place of this 36 we are writing what your n, okay. Now we'll try to represent this in both the forms, okay. One will be your exponential form, okay, and another will be what your, another will be your logarithmic form, okay. Now see, I have assumed that any base a, okay, I am assuming this one, any base a to the power x gives us what your n, okay. Any base a to the power x gives us what your n. Like say here 6 square equal to 36. That means the power of something was there, base is 6. Now in place of 6, what we have here? A, and in place of 2, we have a x here. This in place of 36, we have a what your n. Now see how it's get changed, okay. Whenever you are writing log, okay, see there will be no change in base. 6 was base here, here also base is 6, okay. Just there will be change in what your position of your power and this real power and this assumed real number. That means if I took log of this, then what will happen is that log of a to the power n will be equal to x, okay. This is how any exponential form can be represented in your logarithmic form. Very simple, the base will remain same, you just shift this n to the your top side and this x to the right hand side. Very simple, I did the same thing here, okay. Now here also few restrictions are here. The restrictions is that, okay, the first your here a to the power n equal, that means log base a to the power log base a n is equal to x. Here n must be always greater than 0. Okay, why n must be greater than 0? Okay, I will explain this one later on. Here what we have assumed, any positive real number n, that means it must be positive. So if I accept any number less than 0, which will be the negative, so we are not allowed to accept the negative numbers. Okay, I'll explain why it is not allowed to accept. Okay, again, a is also greater than 0. Okay, a is also greater than 0. I'll explain this one as well. Okay, and another point is here, a is not equal to 1. Okay, clear? The another point is here, a is not equal to 1. So I'll explain all these three reasons, that's all these three, why n is greater than 0, why a is greater than 0, and why a is not equal to 1. Okay, so these are the very basic fundamentals. So hope all of you have understood. Now we'll try to solve few examples now. Okay, so our first question is that log base 8, okay, 512, answer is 3. Now actually why this answer is 3, which means actually the way you are writing, which means what power of 8, okay, what power of 8 gives us 512, it is your 3. Okay, for your convenience, see, I am repeating it again. This writing in this format means your what power of 8, that means what power of this base 8 gives us 512. So the answer is 3, because we know what we know, your 8 cube is your how much, 512. Okay, now this is what, this is the anti-log form. Now this is actually exponential form. Now see, actually the originally we are converting exponential form into what, your logarithmic form. Okay, clear? We are just reversing this one. Now when you are reversing, okay, the idea will get changed here. The idea will be what power of 8 gives us 512, so answer is 3. Okay, the second is your, okay, so the second is your what power of 3, okay, what power of 3 gives us 81. Okay, it is definitely your how much, 3 to the power 4. Okay, it is 3 to the power 4 gives us your 81. So our answer is how much, this is your 4. Okay, next log base 2 4. Okay, now again you see what power of 2 gives us 4, 2 square, 2 2s are 4, so your answer is 2. Okay, now this one is little tricky. See, log base root 2 4 is equal to 4. Now they are asking is that what power of, okay, root 2 or what power of square root of 2 gives us 4. Okay, then you will see here square root 2. Okay, if you write 1, if you write power as 1, then you will get root 2. Okay, then if you are writing 2, power is 2, then 2 will cancel out square root, then your answer will be 2. Okay, but if you write here 4, then what will happen, you see here 2, this square root means what, half. Okay, and over this 4 will be here. Okay, now see here 2, can I write like this, you have to multiply, so 2 divides 4 2 times, so it will be your 2 square. Now 2 square means what, 4. Okay, that means see what power of this root 2, what power of this root 2 gives us 4. You can see when I write power 4 here, then my answer is how much, 4. So answer is your how much, 4. Okay, it's very simple. Okay, then next again they are asking, okay, what power of root 5, okay, what power of square root of 5 gives us 125. Okay, I'm repeating it again, what power of this root 5 gives us 125. So we'll check out here. Okay, root 5, so we need to check the power. We need to write the such a power of root 5 which gives me how much, which gives me 125. Okay, if I write 1, then I will not get. If I write 2, okay, if I write 2, then I will get how much, 5 only. But how much I need 125. So you see, okay, say example I am trying with 4. Okay, then what it will be your 5, this square root means how much, half. Okay, again this 4 need to multiply, you multiply, So this is your 2. Now what is the answer? 5 square, that is your 25. That means whenever you are taking power as 4, your answer is how much? It is your 25. Okay, now let's try with your 6. Okay, let's write power as 6. Now again your square root means half, so 5 power half into 6. Then 2 divide 6 how many times? 3 times. That is, now you are getting how much? 5 cube. Okay, now 5 cube means how much? It is 125. Now see what power of this root 5 gives us 125. That is your 6 na. So answer is 6. Okay, see the way of solving is little different, but I am trying to make you understand what exactly we mean by this format. Okay, this is also done. Then see this one also. Log what power of 1 by 5? What power of 1 by 5 gives us 5? Okay, I am repeating it again here also. What power of 1 by 5 gives us 5? Now see, very simple here. What power of, that means you should choose the base. Okay, what power of this base gives us this number? Okay, now if I write some positive numbers, okay, I will get some fractional numbers only. Okay, but I know if I take -1 here, okay, then what will happen? It will be your 1 by 5, isn't it? Now numerator and denominator will get changed, then you will get how much? 5. That means see what power of 1 by 5 gives us 5? That is your -1. See, when I write minus here, my answer is 5. So answer is how much here? 5 -1. Okay, then see here. The next is your log base 193. Okay, now see they are asking what power of 1 by 93 gives us 1 by 93. Now see, for any number, if the power is 1, the number is itself, isn't it? So if I write 1 by 93 power 1, then I will get 1 by 93. So my answer is your how much? 1. Okay, the 8th number question is your log 1 by 3. Now again they are asking what power of 1 by 3 gives us 1 by 9. So very simple, they are asking what power of 1 by 3 gives us 1 by 9. So you write here 2, then it will be 1 square 1, 2 square is your 9. That means see what power of this 1 by 3 gives us 1 by 9? 2 na. So our answer is 2 here. Okay, see what power of this 1 by 3? When I write 2, then I am getting how much? This one, 1 by 9. So your answer is how much? Answer is your 2. Then the next question is your what power of 81 gives us 81? Definitely 1. If you write 81 power 2, it will exceed 81. So answer is your how much? 1. Then next is your, you see they are asking what power of 1 by root 2 gives us 1? What power of 1 by root 2 gives us 1? Okay, now let's start checking. Okay, the base is your 1 by root 2. Okay, now if you start checking by 1, 2, 3, 4, you will not get 1. Okay, but if you write 0, then you will get how much? It is 1. Okay, that means see what power of 1 by root 2 gives us 1? That is your 0 na. When I write 0 here, then I am getting 1. So the answer is your 0. Okay, then the next is your what power of 97 gives me how much? 1. So definitely they are asking what power of 97 gives us how much? 1. So definitely it should be 1. Sorry, 0. It should be 0. So 97 to the power 0 is always 1. So answer is how much? That is your 0. Okay, hope you have understood. It's very simple. Then we have a last question here. Okay, and after this class we'll try to solve these questions in another way also. Okay, our 12th number last question is log base is root 2 plus 1 and see what power of root 2 plus 1 gives me root 2 minus 1. Okay, it's a little complex. Okay, you can see here, but it's very easy. Okay, it seems complex, but it's very easy. Okay, now what they are asking is that what power of root 2 plus 1 gives me root 2 minus 1. Okay, so I'll show you the solution of this one. Okay, Okay, I'll solve here. So first of all, I'll solve for, now let's say example. I'm taking this 4 number example. Okay, this four number example I'll solve in another way. Okay, actually I have shown you how this is 4, but I'll solve it for you and I'll show you 4. Okay, so say example, this is not known to you. Okay, now you are asked to evaluate log of base root 2, okay, 4. Then whenever you don't know or you have any confusion, then you assume this quantity is equal to x. That means you write let log of root 2 4 is equal to x. So this is how you were taught, I think. Now you can see here, this is a logarithmic form. Now you have to write it into exponential form. So whenever you are writing in the exponential form, this base will go under this one. That means this will be your root 2 power x is equal to 4. Okay, it will be like this. Okay, then you see here, this 2, this square root means how much? Half. So half into x, it will be your x by 2. Okay, and which is equal to 4. Okay, see what is this x? Don't get this x is an unknown quantity. I have assumed that what power of root 2 gives me 4, I don't know. So that's why I have assumed that the power is how much? X. Okay, it's a very convenient way actually, but this is for the understanding purpose, the way I have explained here. Okay, then see here, 2 की power x by 2, this 4 can I write as 2 square. Then see here, base are the same. Now we can cancel it out. So you write x by 2 equal to 2. Then see x equal to cross multiplication, 2 2 is 4. So our answer is how much? 4. Here also how much was the answer? This is your 4. Okay, so this is the way you will solve in the exam. Okay, but this is for the understanding purpose. If you understand like this, okay, no matter how complex questions are given to you, you can get the answer in your own way. Okay, now see, by applying this procedure, okay, by applying this procedure, I'll solve this one for you and I'll show you how the answer, why the answer is -1. Okay, so you see here, the question is your log of root 2 plus 1 root 2 minus 1. Okay, see these examples are taken from the outer sources. These examples are not from your book. Okay, I took from somewhere to make you understand only. Okay, so very simple, this is the question you are asked to evaluate. Very simple, you assume that you don't know, so let this equal to how much? I have assumed it's x. Okay, this is the logarithmic form. Now I have to convert this into your exponential form. So whenever you are converting it into exponential form, very simple, you shift this x to the, x is the power of this base and root 2 minus to the right hand side. Okay, that means it will be like this, your root 2 plus power will be your x and that side it will be your root 2 minus 1. Okay, now see how to simplify this one. Okay, directly you cannot simplify, so what we'll do, we'll apply some another method. Okay, now I will multiply root 2 plus 1 both side. Okay, so I'll explain why I'm multiplying. Okay, now see, root 2 minus, because this is an equation, both side I can multiply by any number. Okay, now see, a minus b into a plus b. Okay, now I can simplify this one, otherwise you cannot simplify this format. Okay, just for the simplification I have multiplied. Okay, now see here, root 2 plus 1 root 2 plus 1, bases are the same. Now can I add the power? Its power nothing means what? 1 is here. So you write root 2 plus 1 power is your x plus 1. Okay, then it will be a minus b into a plus b. So can I write a square minus b square? Okay, then you see here, root 2 plus 1 power is your x plus 1. Then root 2 square means 2 minus 1, that is your how much? That is your 1. Okay, now see here, root 2 plus 1, okay, the power is x plus 1. So this side we have a 1 here na. So can I write this 1 is root 2 plus 1 power 0? Same thing, isn't it? Root 2 plus 1 power 0 is always 1. So I am writing this one. I can write any number, but to match the base, okay, I have write this one. Okay, now bases are the same. Now you can cancel out the base. So what will happen? Power is x plus 1 equal to 0. Now see, x equal to how much? Minus 1. So this is our answer. Okay, so hope all of you have understood this one. It's very simple and it's very easier way. Now see, whatever the examples we have solved, from these examples, okay, we'll come to the certain conclusions. Okay, we'll have certain results. Okay, the results are like this. Okay, the first results, okay, I'll show you. The results are like this. Okay, the first result we got, okay, log of a to the power n, okay, base x. Then in such case, what I have said, a is greater than 0. Okay, this, see, whatever the numbers you have with log, okay, this x can be negative. Okay, I'll show you how. Okay, a greater than 0, again n greater than 0, and a is not equal to 1. See, I'll show you why a is greater than 0. Okay, okay, in the first itself I have said you have to assume such a number which is positive real numbers. Okay, positive real numbers, the number should be real number. Now, okay, see here, say example, if I take 2 to the power 2, okay, see, this a greater than 0, okay, you can take a less than also 0, but it is satisfied for the few conditions only. For all the conditions, our the criteria will not be satisfied. Our criteria is that we must have a positive real numbers. That means, so again, another type of number is also there. This is called the imaginary number. Okay, so you will learn in your class 10. Okay, this is from the your complex number chapter. Okay, but we have a restrictions here is that your answer should be always a your real number. Okay, you cannot accept a imaginary number. See how we are getting an imaginary number. Now here it is accepted. Minus 2 square means it is 4. It is known to all. It is correct. We are getting a correct answer. Okay, now say example, minus 2 power 3. Then also it is correct. I am getting 8. Till this no problem. But if someone asks me to write like this, minus 2 to the power x. Now x is a variable. X is a variable means it can hold any values. Okay, now say example, you ask me to write minus 2 and I am assuming x is a half. Okay, then what will happen? You see here, this half means what? Root over minus 2. Okay, now you should know this root over. Okay, if any number is inside the root in the negative form, then this is not a real number. This is called what? This is called your imaginary number. Okay, this is called your imaginary number. Okay, this is called your imaginary number. So that's why we are saying this. See, that's why we are saying this base should be always positive. Okay, see, because of this base minus 2 only we are getting an imaginary number. So our base should be always greater than 0. See, instead of writing minus 2, okay, if I write 2 to the power x, no matter what value you want, you can write it. Okay, this x can be negative also, you see here. Okay, say example, you ask me, sir, you write minus 1. Then see, 2 to the power minus 1 means how much? This is a half. I am getting a valid answer. This is a real. Okay, now 2 की power minus 3. Then also I am getting 1 by 8. Okay, that means, see, this exponents, this power can be negative. Okay, but this base, okay, that means this power can be, you can see here, this power can be negative, but this base and the assumed real number cannot be your what? Negative. Okay, so this is satisfied. Now you have understood, I think, why a is greater than 0, and you have understood n is also y greater than 0, and a is not equal to 1. Now see, a is not equal to 1 means, okay, if I write any power of 1, any power of 1 always gives us how much? 1. Okay, so you will not get another answer. Say 1 power 100, it is also 1. Okay, 1 power 0, it is also 1. 1 power 2000, it is also 1, isn't it? So see, there is no change. You are getting a constant answer. So we have eliminated this condition that a cannot be 1. Okay, so these are the restrictions. Okay, so these are the restrictions that we have observed. Okay, the second result we have got here. Okay, so when we had log 81 and 81, we wrote how much? 1. Why we are writing? What power of 81 gives me 81? It is your 1. That means when base and the assumed numbers are same, then our answer is always 1. So from there I can make a conclusion that log n base n is always equal to 1. Or instead of n you can write a also, then also anything you can write. That means same number, same, then this is your 1. This is our another result. Okay, again third we got. Okay, now you can see here sixth example. Okay, this sixth example. Okay, 5 1 by 5. Let me see, 5 and 1 by 5 are reciprocal to each other. Okay, so when the reciprocals are given in your log form, then our answer is how much? -1. So from here also I can write a result here. Okay, from there also I can write another result here. So the another result will be your log of, okay, log of n. N here I have a base is 1 by n. Then also, okay, so I'll write here. Okay, which means your log of n 1 by n, then in all the cases this is your -1. Okay, now example here like this. Okay, log 5 1 by 5. Okay, so here you no need to see, you just write -1. Okay, anything log 1 by 7 and 7 is here, you write -1. Okay, so this is our one result. Okay, now another result we have got here. This is going to be the fourth result. Okay, so what we got, log of 97